Now we're going to go ahead and do the law of cosine. They're somewhat similar. They can be used both at the same time for the different things I'll show you. The book doesn't have it, but I know for Algebra 2, I just taught this not too long ago to my juniors, and we used both methods, and they work about the same. They're all by 0.1 of a decimal, which is completely fine. Here, we have the law of sine. According to this equation, it's very simple once I break it down. The main thing you're focusing on is the angle with the opposite side. So here we're focusing on angle A. According to this equation, it's going to be the opposite side squared. So opposite side from the angle is equal to the included side squared. So one included side squared plus the other included side squared, so it doesn't matter which order they're in, minus 2 times the same thing again, but they're not squared this time, 2 times B times C times the cosine of that main angle. What I do is I like to focus on that angle and work my way around that angle. So from cosine A. Here, example 1, we're going to go ahead and find C. They have a word problem in there. Again, for the sake of time, we're just going to go through it. We want to find this part right here. Again, when they have these type of problems, remember the capital and lowercase, that means they're opposite from each other. So capital A, and they have lowercase a equals 5. That would mean that lowercase a is right across from A. B, and then lowercase b, they're right across from each other. Capital C and lowercase c, they're right across from each other, especially when you're actually making these triangles, like in your examples, they'll ask you to create it. Example 1, we're going to find what C is. So here we only have one angle, and we have 2 of the sides here. We're going to go ahead and use the law of cosine. So according to this, we're going to focus on angle C. The opposite side squared, it's dripping from the ceiling. The opposite side squared is equal to the included side squared. So one included side squared plus the other included side squared minus 2 times. Can you see that? Yeah, you can. It's going to zoom in a little more. Okay. Minus 2 times those included sides again. So 388 times 212 times your cosine of that angle. That angle is 82.4. So there's a lot going on here. From this step, just simplify it a step at a time. So here I need my paper. I went ahead and simplified it. So going from left to right, c squared is equal to, for this step, what I do is I do 388 squared plus 212 squared. If you put this whole thing in your calculator, it's going to kind of mess it up and give you a huge difference of an answer. I would just recommend you doing a step at a time. So 388 squared plus 212 squared, so in your calculator, you get 95,488 minus, I did 2 times 388 times 212. I got 164,512. And then I did the cosine of 82. And I'm going to do that later. Cosine of 82.4. So this squared and add it together, I get that. Minus 2 times these numbers, I have that, times the cosine of 82. Now, I go ahead and simplify from this section here. So c squared is equal to 19488 minus this whole thing. When I multiply it together, I get 21,757.7632. Try to keep it within 4 places until the very end, and I round. Now I subtract those two. I end up with about 1733730.2368. So I get a bunch of decimals. In the end, you square root both sides because it's a c squared. So c is now equal to about 416.8. And that's going to be your measurement from A to B. You're going to round the tenths place. The book says it's about 417 spaces away. So if you have in tenths or in whole numbers, I'll let you know how I want you to round it on your books. Here, example 2. So they gave us a triangle. They said A equals that, B equals that, C equals that. Keep in mind, remember they're opposite from the angles. I always draw a triangle like this, A, B, and C. My 2 bases are A and B, and my top is C. Here we're going to use the law of cosine, and I'm going to apply the law of sine to find all the missing sides. If you notice here, there is no angles whatsoever. When there's no angles whatsoever, you cannot apply the law of sine. Here I'm going to apply the cosine. So I'm going to go ahead and I'm going to erase that there. Go ahead and I'm going to find angle A. So angle A, I always focus there. It doesn't matter which one you do. So here, I'm going to focus on this angle. We always look at what's across. So that means it's 5 squared is equal to the included sides of angle A, which is 8 squared plus 12 squared, minus 2 times the 2 included sides again. Included means right next to it, and when they connect and they meet at that one angle. So 2 times the included sides again, so 8 times 12, times the cosine of that main angle, which is A, and I don't have anything for A, so I'm gonna leave it like that. So here, my variable is not at the end, it's at this end over here where the cosine is. So now we're gonna go ahead and do step by step by moving everything to get the cosine by itself. Here, but simplify everything. 25, 5 squared is 25, 8 squared, 64, plus 12 squared, 144. You end up with 208. Minus 2 times 8 times 12, I got 192, and then the cosine of 8. Here we have like a two-step problem. We have this minus 192 times the cosine of 8. I'm going to go ahead and move this over so I can get the cosine of 8 by itself. To do that, opposite sides, I'm going to subtract 208 to both sides. And then 25 minus 208, I end up with negative 183 equals negative 192 times the cosine of A. Trying to get the cosine of A by itself. You're going to divide both sides by negative 192. When you do that, you have the cosine of A is equal to, you have a decimal 0.9531. Again, I like to take 2 places, actually 4 places. Keep it there until the very end. To get the A officially by itself, I have to do the inverse cosine. So you have to do that the very last step. So the inverse cosine to both sides, and that gets the A completely by itself. The inverse cosine of 0.9531, I get about 17.6, and the book rounded it to 18 degrees. It's okay if you rounded it up, you leave it there. A lot of these answers will be off by a couple, tenths of a decimal. It can be off by 1 or 2 degrees, and that's completely fine. It all depends on how you round it. But I mean, for you might put everything in one step or up here, down here, and it's going to change your decimals a little bit. But again, that's fine. Here we have angle A. Angle A is about 18, so they have there. Just keep it as a whole number. I would recommend keeping it in tenths, but they have it as a whole number here. So we have 18 degrees here. Now for B, we have to solve for it. For B, what I'm actually going to use is the law of sine. The law of sine, I feel like it's a lot easier to use because all you do is cross multiply and you're good. We can use the law of sines for this one. We have what A is for both A's. We have the angle and we have the side. I'm going to go ahead and try to find the angle B with that. So the law of sine is the angle, the sine of the angle, which is now 18 degrees, over the opposite side, which is 5. Set it equal to the sine of, I'm going to put B because I'm trying to find B, over the opposite side is E. Now, from this point, you cross multiply. So you have 8 times the sine of 18 times 5 times the sine of B. To get the sine of B by itself, divide both sides by 5. The sine of B is 0.4944, and then the very end, find the inverse sine of both sides. And when you do that, you have angle B is equal to 29.6. Again, I'm off by 1 decimal, so they rounded it to 29. I'm going to round it to 30 degrees. Easier for me, it's off by 1 decimal, it's completely fine. But using the law of cosine, law of sine to solve for an angle, they're both the same. The law of sine is a lot easier to use. But there's only certain instances when you can't use the law of sine, and that's where the law of cosine comes to play. That's why for the first one, we had to use the law of cosine. Now, we have what A is, we have what B is, and C, we don't have to do the law of sine, the law of cosine. We can just go ahead and add those 2 angles together and subtract it by 180. So if we add those two and subtract it by 180, we can find our measurement for angle C, and that's about 132. The book has 133. Again, they're similar. I'm completely fine with one decimal place off. And that's finding all three of these 132. So whichever way works for you, if you want to use the law of cosine for all of them, go at it. If you want to use the law of sine, that's fine too. Last one is example 3, and I'll show you why you can't use the law of sine to solve for that first part right there. Here we have, if we look at the opposite angles in the sides, for angle A, I have the degree, I don't have the side. For B, I don't have the angle, but I have the side. Angle C, I don't have the degree, but I do have a side. And each one of those three parts, they're missing one thing in it. When you're missing one thing in it, you can't use the law of sine, because according to the law of sine, one of them has to include both the angle and the side. So you can't. Now let's do the law of cosine. Example 3, they want us to find the missing parts, which is angle B, angle C, and lowercase a. Here, let's see what I did, so I can go step by step. I want to solve for the side A first. So we're focusing on this angle, and we're focusing on side A. So that means I have A squared is equal to, so the opposite side here, is equal to the included sides, 10.5 squared plus 18 squared, minus 2 times, again, the same included sides, 10.5 times 18, times the sine, or actually the cosine of that angle A, which is 46.5. And then we go ahead and solve. This squared plus that squared, you end up with 434.25. There's so many decimals, that's why you can be off by a decimal or two. 434.25 times this here, you get 378 times the cosine of 46.5. You could put this all together, which that's what I did. It's too much work for me. I got 174.05. Again, last part, try to find the side, square root both sides to find A, and the A is about 13.2. So I have 1. Now I can find the angles here. I could use a law of sine now, because now I have one angle and one angle and side that has both of them, and that is your angle A. So I have the sine of A, which is 46.5, over the opposite side, which is about 13.2, set it equal to, I'm going to find angle B. So angle B here, so the sine of B over the opposite side, which is 10.5. Cross multiply, we have 10.5 times the sine of 46.5 is equal to 13.2 times the sine of B. To get the sine of B by itself, divide 13.2 by both sides. You get the sine of B is equal to this. I do 10.5 times sine of 46, put the equal on the calculator, then I divide it by 13.2. I end up with 0.577. Last step, inverse sine both sides, and then you get B is equal to 35.2. So keep in mind, you're doing inverse sine, not the actual sine of it, and you have about 35.2, or you have about 35. Again, I would recommend you rounding to the tenths place, makes it a little bit more accurate. So now I have 35.2 for B. And now for C, easiest. All you do to find angle C, you have 180 minus the sum of the other two, so which is 46.5 plus 35.2. And angle C will give you about 98.3 degrees. And that's how you find each one of your missing sides. They both work out. You can use a law of cosine. Again, it's so much work. I prefer a law of sine anyways. All right, you guys need any help, let me know. If you guys are missing anything, you want to see what you can catch up on, let me know. I can help you out. We will have a test on Thursday, not on Friday. There's not going to be any work for Friday for both of us. So have a good day.